So why is it that a ship can float, but something as small as a needle sinks in the water? Well, it turns out that the determining factor of whether something sinks or floats is neither mass nor volume, but rather a combination of both. Whether something sinks or floats is determined by volumetric density, which is denoted by a Greek letter rho, and it is equal to mass over volume. And basically, if an object sinks, that means that the density of the object is greater than the density of water. And conversely, if it floats, that means that the density of the object is less than the density of water. And same token, you are, you, and the less dense you are, the harder it is. This is next time you're in a pool, try inhaling oxygen and try to like flap your arms to make yourself sink, and you'll find that it's kind of difficult to do so. Whereas if you completely exhale and you have no air in you, you'll float a lot easier. And the reason for that is because the air that you inhaled is obviously a lot less dense than the water, so it decreases your average density. So then what does dictate whether an object floats or not? So basically, let's say we have a surface and we have some water and we have an object at the surface of the water. So the forces acting on it, well, obviously there would be gravity, but then there would be another force, and that's the force that dictates whether it sinks or floats. And that force would be the buoyant force acting on the water. And the formula for the buoyant force is the density of the object times the volume of the water displaced, or in other words, the volume of the object times the gravitational constant. But times the volume of the object, or the volume displaced, times g, which is the gravitational constant. And we can see, if we compare the two, we can cancel out the volumes, and we can cancel out the gravitational constant. That the remaining variables are the densities, the fluids, and the object respectively. And that's why, like, an object's density dictates whether or not it sinks or floats. This, if the density of the fluid was greater than the density of the object in this case, then basically this mg value would be a lot shorter than the value of the buoyant force. Okay, this is kind of inaccurate because then it would accelerate upwards, but you get the idea. As if the density of the object was greater than the density of the fluid, then the downward pointing force vector would be greater than the buoyant force. That is as small would sink because the metal is composed of the water, whereas something like a cruise ship is full of air, which just decreases its average density. Its average density is lower than water. Yeah.